Hey everyone, I'm Mike Peel, host of Full Crew, and we've got some great topics we're going to be covering today, including automation and robots in construction. We're going to be talking about smart cities and how they're going to become increasingly important, and therefore, are these network cities going to support more complex robotic systems? We're also going to be talking about increase of use in the service industry, hotel and restaurants of robotics. And then we're also going to be talking about, at the end of the show, the ethics of killing autonomously, which sounds like a deep topic, but it's also increasingly important on the home front as police are asking to use robotic systems in hostage situations. So we've got some great guests to talk about these hot topics today. I'm going to start clockwise order. So Leo-Pol, tell everybody a little bit about yourself. Oh, you're muted.
Hey, I'm Leo-Pol Watrin. I come from France, direct from here right now. I am robotics engineer. We have created the first robotics concept store in France, where you can have advice and live demonstration of any kind of robotics, like educative robots, vacuum robots, and to industrial and cleaning robots, with a large and one of the largest database in robotics in the world for free online to make accessible robotics to everyone.
Well, excited to have you here, and I know Dom was excited to have you on too. Next up, we got Renee.
Hi, everyone. I'm Renee Welch. I am the Executive Administrator and co-CEO for Robotics. I'm happy to be here today. I'm also a recent graduate of the first cohort for Leading Smart Cities with Trust, which is a professional program through Syracuse. So I look forward to talking to you about smart cities.
Well, excited to have you here and excited to see you again. I hope I'll see you at Exponential soon also. And then we have Sean Guerre, who's a longtime guest of Dawn of Autonomy, Dawn of Drones before that, and a big friend of the crew. He runs an amazing event, which this year will be in June, but I'm going to let him talk about that. So, Sean, tell us a little bit about yourself.
Thanks, Michael. Howdy, everyone. Sean Guerre, I'm Executive Director of the Energy Drone and Robotics Coalition, and we're a community of about 16,000 folks globally who are involved with the operations and scaling of drones and robotics, and obviously actionable data for the energy, includes oil and gas, power and utility, and the industrial communities. And we do that with events and news and reports.
Thanks, Sean. Happy to have you on another show. And last up, but not least, Walker. Walker, tell us a little bit about yourself.
Good morning, everyone. So I'm Walker Gosich. I am a sixth-year PhD student at the University of Pennsylvania studying robotics and artificial intelligence, so nearly to the end of my degree. And I work on AI for multi-agent systems, and actually part of my work was geared towards autonomous construction at a lot of the beginning, so I'm excited to talk about that topic. And I've also worked a lot in the policy of robotics and artificial intelligence. I'm a leader of the Penn Science Policy and Diplomacy Group, which is a group of grad students, postdocs, and professors here at Penn that are engaged with sort of what happens with our science outside of the lab. And I've worked in that capacity a fair bit on autonomous weapons systems and sort of the ethics, the policy, and what we as a robotics community can do to address some of these challenges. So I'm very excited to talk about that today. Thanks for having us all on, Michael.
Yeah, excited to have you on. I had the fortunate benefit of visiting the UPenn GRASP Lab, and it's an amazing facility in terms of what they're doing there. As far as research in all fields of robotics, included aerial. That's how I ended up there. And you come recommended from a good friend, Fernando Cladera. So excited to have you on. We're going to move on to our first article after I briefly thank our sponsors, which are Axon, ASTN Group, Airspace Link, Carasoft, and Drone Responders. We thank them for making this show possible. Also, this is live, so if you want to participate in the chat, please do so, even if it's just to say hi. So Sean, first up, we got your article here. So what's going on with autonomy in construction?
Awesome. So excited to talk about it. And I guess in the spirit of opening season for baseball, I'm the leadoff batter. So looking forward to talking about what grabbed me right away was along the autonomy road. I mean, obviously, as we look at the scale of autonomy and the excitement around drones and robotics and getting those to a more autonomous playing field, I would say, in operations and projects. So that's what really drew me to this article from Inside Unmanned Systems. And when I unpack within it, and I'll go through the highlights with everybody today, it opens up a lot of the areas that I think, really make up that road. How are we going down that road? And the first one is looking at some numbers, which are kind of, boring for some people. But when I look at these numbers, they're very exciting. And what I'm talking about is, for instance, they had a business research company's autonomous construction market report. They're looking at over $1 billion of growth in autonomous construction equipment market size year over year from 23 to 24. So that's always exciting to see that kind of fast-paced growth within just a 12-month cycle. When we take that and expand it a little bit longer, there's actually another report from IMARC, which talks about the global construction robotics market size and looking at reaching $504 billion by 2032. That's $500 billion, in the next several years. So we're talking about very fast growth in the short term, and especially, when we look at its exponential growth in the longer term, 14% compound annual growth rate. So that was one of the first things, was looking at the size of the market and how fast it was growing. So the next thing that really kind of laid into, from our perspective, was they started talking a little bit more around some of the research projects. So some of the early days and what's been happening at places like Los Altos with Toyota Research Institute, and how the robots are taking on all new characteristics. So it's not just a flying drone or a rolling crawler. I mean, those are being utilized by all means, but they've got robots now that are in the humanoid area, which is obviously a very exciting, fast-paced growth. As these robots and their dexterity, it's amazing. I mean, honestly, these things are painting and pouring and doing all kinds of other work that exceeds greatly what they've been doing in the past, not just lifting and inspecting and marking, which are some of the big base load that the initial robots were doing. So this dexterity is like over 60 different dexterity solutions that have been developed and are now going into the proof of concept and field trial market. So I thought that was very interesting as well. Obviously, then they started to talk about a little bit around how this is driving productivity, because it's either assisting the workers who are there today, making it safer, making it easier for them to do large projects around scaffolding, all kinds of areas where they're able to work around renewable energy. So in a variety of different construction projects. And the fact is that these are in no way really at this point replacing people. They're filling gaps. There is such a large demand for workforce in the construction industrial industry that at this point in the phase of adoption, these are really helping and assisting and filling those gaps. They're not really showcasing a great change in the workforce taken over by robots, which I know is obviously brought up quite a bit for people to discuss. So that's something I think that was interesting as well.
Go ahead. No, there's so much interesting to kind of tackle there between using robots in environments that are just not really safe for humans. And it's kind of bad that we use humans in those situations or environments now. But also the rise of computer vision allowing for these new level of task complexity on top of the developments and, like you said, dexterity. Robots can actually fold clothes now, which is not something we used to be able to do with them. So I guess that makes them better for mixing concrete too. Renee, do you have any questions or comments about Sean's article?
I sure do. This is fascinating. I'm wondering if you could share a little bit about how you provide and bring awareness and education to your potential customers or even any stakeholders, since this is new. And a lot of people have the tendency to think that robotics will replace workers, but you said it, that's not the case. How do you explain this?
Sure. So thanks, Renee. Basically, from our standpoint, the Energy Drone Robotics Coalition tends to be almost like singing to the choir in that term. We have mostly people who are at least interested or have questions about adopting drones and robotics into their projects and operations, all the way to folks who are fully scaled. And really three sets of stakeholders: asset owner operators, people who run oil and gas pipeline power utilities, as well as service companies who do a lot of the work for them: inspection, surveying, mapping, as well as construction. And then we also have obviously the solution providers. So in all those stakeholders, they're somewhat unified in the interest of adopting and scaling drones and robotics in their projects. But what we help them with, I think, to your question specifically, is give them information about how, whether it's use cases or best practices or top trends, how this is making things safer, right? We're getting rid of the dull, dirty, dangerous, the 3Ds. Those are the things that we're trying to remove. And that's where drones and robotics are able to really make an impact, so that it showcases to the workforce two things. One is, this is something that's going to enable safety and help you in your productivity and make it where you're not working as hard in order to achieve even better results and safer results. And on the other side, when we have a lot of folks coming out of millennial, Gen Z, soon to be Gen Alpha, who are coming into the trades and into these industries, whether it's engineering or skilled workers, welders, et cetera, they're very tech savvy. They're digital natives, and they're looking for these type of tools to be available for them. So it's also, I think, meeting them where they are, which is wanting to use these type of technologies, and it makes what was formerly, I think, older industries more exciting.
Fantastic.
That's an excellent point.
Mhm.
Walker, Leo-Pol? Anybody?
Yeah, I wanted to jump in with some questions. I'm really curious, because autonomous construction technologies span the whole gamut from, the stuff that you mentioned that is more on a human scale, like, drywalling, some scaffolding work, some painting, all the way up to these, autonomous, like heavy machinery that like Caterpillar is developing, for example. And so I'm wondering what the what the workflow looks like in these different scales, having humans and robots working together in the same work sites. First of all, how do you communicate to the workers and train them up on how to best use these technologies? How do you set sort of safety bounds around some of these technologies, especially the heavier tech that could potentially, cause some dangerous situations? Yeah, and generally how you communicate about that to the people who are going to be using this stuff and deploying it in the actual work site.
Yeah, that's a great question, Walker. And definitely you have a couple different aspects of that, right? So you have that, co-working situation or cobots where you have workforce and robotics on the same job site. So how is that being worked on? And interestingly, I could point back to the article. There was a highlight box about the look inside a fully autonomous job site. And the University of British Columbia Smart Structures Lab in Vancouver is working on specifically AI and drones and robotics and humans all being involved on this test work site together to try to develop best practices and to make sure that, to your area of expertise, the AI and ML is being utilized in a way that is safe for the workers in the area, with all these different types of robotics, which, as you mentioned, are all different sizes, from very large in some of the initial development of the structure down to smaller ones. So I thought that was very interesting to talk about, that, what areas they were focusing on, and that you do have these test sites that are being built right now to, in fact, make sure that the area that you're talking about makes it where it stays safe.
I think people underestimate how much work goes into developing engineering robots because of the complexity of the physical environment, right? And there's no more kind of environment that's constantly evolving like a work site, right? That's the nature of it. So that's an interesting point that Walker brings up, that you actually almost have to create a new language for the humans to understand, like, using this robot, don't stand here or there. When this problem arises, this is what you do. So you have to train them up on the behaviors, because the robot's going to do what it's going to be programmed to do, even if it does have more complex systems like computer vision and such. As we saw with anything automated, when there was the cruise incident, it actually did what it was supposed to do after it hit the woman, which was move to the side of the road and park. But that ended up in the situation where the woman was dragged. So you would absolutely not want that situation to happen on a job site. So it's really cool to hear that they're actually setting up almost a test bed to develop this new training language. Any final questions or statements about this article before we move on? Sean, you want to give a summary statement?
So one of the summaries would be some of the early adoption that was in that proof of concept field trial is absolutely now scaling. So using drones and for inspection, for keeping track of quality checks, using crawling robots for marking of areas, and using autonomous equipment to do some of the dirt work, around the Caterpillar and the tractors and the Bobcats. That is absolutely scaling, which is exciting. The numbers are great, which is showing a compelling reason for this to occur with the changing workforce, and the technology, to your point, Michael, between AI, ML, things like 4D imaging radar, which goes way beyond the initial LiDAR, showcases where this may be headed. So I think it's an exciting time for robotics in construction, and I think we definitely are well down that road to autonomy. Yeah,
certainly something to be excited about. So when are we going to see the Construction Robotics and Drone Alliance?
It's still a subset within Energy Drone and Robotics for sure, because we're always doing a lot of construction in that marketplace, but definitely something to be looked at.
All right, well, give me credit when you launch that show.
Absolutely.
So next up, we got Renee's article on smart cities. So Renee, tell us a little bit about smart cities and what's going on with the evolution of them.
Sure. I'm deeply interested in this topic, in this smart cities movement. It represents a transformative approach to urban development, and it offers the opportunity for us to harness technology and innovation to address some of the pressing challenges that face our cities, especially as our cities around the world get more crowded and complex. We have a need for innovative and effective solutions. And I think the smart city movement gets us a step closer, as I've witnessed firsthand the potential of technology to bridge gaps and empower communities. So to me, smart cities offers a platform to leverage these skills and experience towards creating a more sustainable and inclusive and resilient urban environment.
So one of the things I wanted to ask you is, smart cities is a broad term, right? But ultimately, its success kind of hinges on connecting disparate technologies and allowing them to communicate. So what do you think a new level of awareness for putting all these sensors into what used to be dumb systems like traffic lights, et cetera, actually brings to urban development, and how do we get those things more connected?
I think it brings, definitely enhances efficiency and effectiveness of cities. You can find technologies and advancements in waste management, anything from waste collection to sorting and recycling, all things leading to a cleaner environment. Definitely optimize traffic management. We're seeing the autonomous vehicles. We're seeing the robotic traffic controllers, and even ways that traffic flow can be improved. We need that. I also see this technology around enhanced public safety. So robotic patrols and monitoring can help boost safety measures. I'm from Chicago, but I'm in Las Vegas, so I'm really mindful of detecting and responding to potential threats. Also, you can see it in improved public services, like assisting in delivery services, the transportation of goods in urban areas, and also in disaster response support. So I see these being just connected technologies and solutions to enhance the infrastructure, energy usage, all things aiming to improve urban living while even reducing the carbon footprint. I think the key will be for researchers, stakeholders, community members to all kind of come together and communicate and share the issues and how these technologies might help solve some of these urban challenges that we're facing.
Awesome. I wanted to open it up to the panel to come up with some of their ideas for how robots might be implemented in a smart city situation, and then what we would need to actually build in terms of infrastructure to support those robots and their success. Any ideas? Who wants to raise their hand? Sean?
Yeah, so I'm very interested to know, Renee, from the article, it was just very interesting for me, is, looking at, I know how complex it is on an energy project, which has a lot of moving pieces, and now you're taking that to a city level. And so I was curious to know what the thought was, or if there was anything referenced in the article around the idea of how you're going to integrate all of these different, so, think about all the different robotics that might be involved in the areas you were mentioning: waste management, transportation, delivery. You've got so many different aspects. I'm curious what the thought process is there on how to coordinate or manage multiple types of systems at the same time.
I think it's going to be pretty interesting. I'll also say slowly and one piece at a time. I really see from what I've experienced, Las Vegas was on its way to becoming a smart city, and Chicago is actually one of the cities in the article that has a urban sensing project. I think the key is going to be that collaboration between the researchers, city planners, and policymakers. They've got to bite off just slow chunks that can't all be done at the same time. I think from what I'm understanding, the first step starts with what are some of the problems being identified and some type of needs assessment, right? Then we have to get into technology integration and implementation. But we've also got to allow for these regulatory frameworks and the policy development behind it. So this is a big job. It doesn't happen overnight. There's also a level of public awareness and engagement and acceptance that we have to have. As you mentioned, Sean, just getting this word out and figuring out how we're going to engage the public and other stakeholders for understanding. Then there's going to be a big piece on the data part, data sharing and analysis. We've got to go through a testing and evaluation phase. And ultimately, this will lead to education and workforce development as well. So I think there are so many moving pieces. I'm noticing that we've started with a major committee here, and they've gone around studying smart cities, such as the 10 or 12 that were mentioned in the article. So I think this is a really big feat, and there's actually a conference coming up soon around smart city initiatives.
Awesome. Leo-Pol, any interest in robots in smart cities? Any ideas for how robots would fit into a smart city architecture? Can you hear us?
Cool. Sorry. No, yeah, we have so many examples. We need to see how a comparative tool. So not exact example here.
Walker, what about you?
Well, Renee, I really liked how you brought up engagement with the community and stakeholders and also urban planners on these issues. I think that's definitely a really important step. I was wondering how and technologists who are developing smart cities technology generally consider the challenges related to equity with integrating these technologies. I feel like there's a history of tools like this being used sort of first on more of a surveillance basis, and that disproportionately tends to impact, those who are impoverished or those in minority or underrepresented populations. And I think that can generate a lot of distrust in these technologies. So I guess I'm wondering how you engage, responsibly as a technologist, as someone who's trying to develop these technologies that could potentially really help cities run more smoothly, how you engage with members of the public, with communities, to ensure that their needs are being represented and that they're not feeling like these technologies are sort of, impinging upon their rights.
Hmm. Well, that's a big one. And I've noticed, for instance, again, I'll just use Las Vegas for an example. I've noticed sessions where they've attempted to address um, equity, security, and privacy, really big issues. It's hard to do because at the same time, you see things like I'm remembering the stoplights who had some type of sensors, but the sensors were not responsive to people of color and melatonin skin. So they were picking up, you know, everybody, to be honest, and that became a problem. So I think the first thing that I've noticed cities doing is doing small testing and then going back to explain and engage the public. And this testing has to include all members of the community, not just one subset. So I'm not sure if I can answer that fully, but that is a major challenge. In the meantime, these technologies, we're going to have to do something about educating the public because we have such a widened um, digital divide now. So that is already a problem with those who maybe don't have an understanding or don't have access to technology. So now to be able to go out and have your face detected by a stoplight is a whole nother situation. So I don't know. That's a question that I've asked that not many have been able to explain to me. So I think I'll have to go to a smart city with some of these things in place and look for that answer myself. It's interesting question.
There's an interesting example in New York where drones were used to surveil a specific population. I don't remember the ethnicity, but to deter violence after an ethnic pride parade. And the violence had happened at that parade 3 years prior. So they had 3 years of nothing happening, and now they're deploying drones over backyards in Queens and Brooklyn. And obviously the public pushback was vast because the only requirement to deploy this drone was a noise complaint, which I don't know if you've ever been to Queens or Brooklyn, but like basically we would have drones flying all the time then. Conversely, though, we had drones walking in Times Square, and nobody had a problem with that because it's a patrol that's only enhancing a public safety initiative that makes people feel better. But interestingly enough, I'm pretty sure that got shut down because of budget. So you have two things here. Is the technology affordable enough to actually deploy and sustain it? Because every time you start from scratch, it's also very hard to get going again. But then, are you communicating with the population that this technology is going to be deployed to? Because if you don't get their support, it's very easy to vote no on the next budget also.
Yeah, this requires big budgets. And I think another point to get across is how it can enrich the residents' lives, improve infrastructure, maybe even update and modernize government services. So I think it also depends on what piece of technology we're talking about. Some things will be available to just enhance accessibility versus other things that maybe accelerate economic growth. So I think it depends on what area we're talking about and how residents perceive the usefulness. But yeah, this requires a pretty big budget in addition to technology always evolving.
Yeah, and it's only going in one direction. So I think that's a good point to move on. I want to thank our sponsors for today. That's ASTN Group, Axon, Drone Responders, Airspace Link, and Carasoft. We really do enjoy their support of this show and everything on the full crew. So our third article is going to be from you, Leo-Pol. So we're talking about what's going on with robotics in restaurants and service industries like hotels. So give us a little bit of a rundown what's happening in terms of progress there.
Yes, thank you again for your time. So yeah, the article made especially for today is about the robotic revolution in hotels and restaurants. So where we tried to make in-depth analysis of the advantage and disadvantage of those robots. I took this subject because we at Robotics actually are recording almost like 300% and plus and demand for those two kind of products. And so yeah, in this ever-changing economic landscape, the hospitality industry is at a crossroad, seeking innovative solutions to meet modern challenges. Among the solutions, robotics is emerging as an enabler of transformation, promising increased efficiency, reduce costs, and improve customer experience. And so today we are having to take a closer look at the pro and to if it's good to integrate the table service robotic and a professional cleaning robot, highlighting current trends from a company like Robotics. So yeah, first we saw improve operational efficiency for table services and cleaning robot in carrying our daily task in the field of cleaning. For example, a robot equipped with advanced sensors can map and clean large space methodically and precisely, reducing the time needed to maintain the cleanliness of premises. I like numbers, so I will give some. And so according to a recent study by research firm Technavio, the global cleaning robot market expected to reach like 27 billion by 2025, driven by growing demand in the hospitality and restaurant sectors. And robots provide also a clear reduction in long-term costs, while the initial investment in robotics may seem prohibitive for some businesses. The long-term savings are significant. For example, in front of a traditional cleaning crews, with a robot can lead to a reduction in labor cost of up to 20-25%, according again another study by Oxford Institute. Robots that are profitable from the second year, between 12 and 18 months. So yeah, robots are adaptable, have versatility. One of the key is ability to adapt to various environment and navigate through crowded restaurant space, while cleaning robot can be configured to handle a variety of surfaces and covering from tile floors to thick carpets. So yeah, so this versatility allows businesses to maximize the use of their robotics investment in a range of operational contexts. The last point, the last advantage is robots offer improved customer experience, integrating a robot in into hotel and restaurant operation can provide an customer experience. For example, a table service robot can not only deliver food quickly and accurately, but also entertain customers, replay for interaction, give some menus, the next movie in cinema, etc., etc. A last study from a market research firm found that 75% of customers consider automation to improve their overall experience at restaurant and hostel. And so, yeah, that was advantages, and however, we remark that there are associated disadvantages. Okay, first of all is the high initial cost. Who are that are according to Robotics the most important obstacle for all our customers despite the clear profitability. Okay, so yeah, the acquisition and installation of a professional table service or cleaning robot can represent a significant financial investments dependent other factors such as the complexity of the robots, its features and capabilities, etc. But yeah, as example, a high table service robot with advanced voice recognition and autonomous navigation features can cost up to $20,000. And then up to $60,000 for autonomous cleaning. Okay, so yeah, and that's the first disadvantages. And robots have also from the beginning faced technological dependence and risk of breakdown. Robotics offers many advantages. It also carries risk. Robot breakdowns or malfunctions can cause disruptions in operation and costly delays. So to mitigate this risk, a company must invest in preventive maintenance program. And train the staff to manage possible technical problems.
Sorry, we got to move on a little bit, but for anybody who hears the disadvantages and think that those are huge mountains to climb, well, yeah, the big number is risky, but we're seeing this technology deployed even here out on Long Island, which is a suburban area. It was one thing when I was in Japan and I saw a fully automated restaurant. It's a whole other thing when my mother tells me about that experience coming to the suburbs. I was kind of shocked, actually.
Yeah.
So it does mean that this technology is more accessible and that people are willing to take that risk. Probably COVID was a big selling point for people to look at alternatives. But what are your thoughts about the expansion into areas like suburban and rural areas with this technology?
Yeah, that's exactly what I wanted to say just right after. It's about the human aspect. We also lose this human aspect where customer services and human interaction are often valued. Okay, and the excessive use of robots could lead to dehumanization of the experience. So some customer may prefer interaction with human staff, and overabundance of bots could detract from the usability and authenticity of the experience.
Yeah, and those are excellent points, because the fully automated restaurant in Japan, the food was kind of meh. It didn't compared to the touch of a good chef. Although there were other experiences that were semi-automated in Japan, like conveyor belts and wait staff, where you just put the tray, it was rolling around consistently. iPad ordering and things like that. For the setting, it felt perfect, right? So I think
Yeah.
what you're seeing in the deployment out here in the suburbs that my mother witnessed is businesses finding the right balance for them and the experience that they're trying to sell.
Again, you just said it again. Robotics is used depends of needs. Okay, if you want to go quicker, just and with more fiability, just use a conveyor for your food in this Japan restaurant example. But yeah, there is so different technology, existing technology today that finally creates new needs. And again, that's what we see in Leo-Robotics.
So Walker, Renee, Sean, any comments about the increase of robotics use in hospitality and restaurants?
Well, I'm here in Vegas, so I actually see the robot arms and robotics in bartending and making drinks. And I'm just curious. You need to come on this way to Las Vegas, as we have a number of hotels and restaurants. That's so interesting, and it certainly fits into my smart cities framework.
Well, does the robot give a heavy pour like my favorite bartender or not?
But that's a new good example. We were in Las Vegas too. I bought this automated drink around like maybe $15, but it was only for the experience. I was so fascinated by this metal robots who just shake my cocktails. But again, there are still one human just right after to welcome you, to explain the concept, and still here to be at your services if you need it.
Mm-hmm.
Sort of reminds me of elevator operators. That was the thing we had until we got used to the full level automation of
ease us into the
elevator.
transition.
Yeah. Any last thoughts, Sean or Walker? You want to take a
Yeah,
bite at it?
Leo, I'm curious because to me, robots have always been very successful in factory-like environments where the immediate surroundings of the robot are tightly controlled, very predictable. The robot can do repeatable things. And I feel like in restaurants and hospitality, we see two types of applications. One being this type where the robot is basically sealed off from the consumer. Maybe it's making drinks, maybe it's making a coffee beverage, maybe it's assembling the ingredients of a salad, and then serving it to the customer. And then there's other applications, for example, in sushi restaurants where the robot is taking trays around tables in these crowded, chaotic environments. I'm curious, you talk a lot about growth of the robotics industry in hospitality and restaurants. Do you think that growth is primarily in these areas where the robots are closed off from the consumer, or is new technology enabling us to grow in the areas that are more in these uncertain and chaotic applications?
I would say both. We see it in Robotics, and also that's what I say every time we see new customers. But yeah, I would not have had this pitch like maybe 10 years ago. Robotics wasn't ready for the customer. I said also for the vacuum. I say for the vacuum cleaners robots. When the first customer tried the first robot arriving in the market, it was not really technically ready, and then first customers were disappointed. And then they just let the robot in their house. And today, technology works, and then we have more and more needs. But again, I agree with you. It's more profitable for larger industry factories for sure. There are some money, and when the particular when at home parents wants a robot who makes everything and for less than $500. Okay, so yeah, there is some difference between both.
Great. When you brought up the topic, I wasn't expecting to go that in deep to it, but thank you for bringing all the statistics to fore. And my real world experience is starting to match with the excitement. Whereas even me, as somebody who understands robotics, if you asked me 3 years ago that we'd be seeing these in these more complicated environments in the customer zone, I would say maybe. I mean, why would you use a robot, right? That's always the first question you ask when you make a robot. Why do I need a robot for this?
Exactly.
But we're starting to actually see some advancement there that is making people comfortable with the robot being there. It's reaching a level of service that I think is interesting. So our final topic is really deep, but it's something that has been on my mind a lot, especially as I work in the drone industry and a lot of people are looking for profitability, and companies that wouldn't even think of working with the military in the past are suddenly making these considerations. So Walker, why did you pick ethical and technical challenges in development, use, and governance of autonomous weapon systems for your topic today?
Yeah, well, it is a heavy topic, so I definitely appreciate everyone's time and attention to this today, because I really do think it is important for us as a robotics community, industry, academia, and policymakers to be really engaging with this topic and sort of facing it head on, because the reality is that autonomous weapon systems are already in use. So we need to reckon with how they're being used and ensuring that they're being used in as responsible a way as we can. We're already seeing autonomous weapons in use in Ukraine. Israel is using autonomous weapons in Gaza right now. They've been deployed in Libya. So there's many uses of these autonomous weapon systems manufactured by the US, by Israel, by defense contractors. And so I think we really need to reckon with, as a community, how we can put guidelines around developing and using this technology that is in concert with existing human rights law and that is in concert with our morals and ethics as a community. So maybe briefly to sort of lay out what we're talking about, what are autonomous weapon systems? It's a tough question. I believe in the article, it's their first item on the to-do list is basically we need to come up with a common language. So we don't have common internationally recognized definitions for autonomy in weapon systems right now. And to a degree, there's always been autonomy in weapon systems, right? Like even if you shoot a bow and arrow, there's an extent to which the outcome of your use of the weapon is out of your control once you've taken this action. That arrow is autonomous. A bomb falling on an area is autonomous because you don't control exactly what happens after you've released the bomb. Missiles have been guided for a long time. So what's different now? Why do we need to have a new and more deep conversation about these topics? The difference to me is the scope of the application of autonomy in these technologies. We are now, with artificial intelligence, with computer vision, we are at a point where autonomy is able to select and engage with targets, and that is happening in these examples, these use cases that I talked about. So the article that I brought to everyone today is by the IEEE Standards Association. They convened a group of experts to really break down the state of the field and what are the primary challenges in reckoning with the ethics and the policy decisions around autonomous weapon system development and use. And there are, of course, ethical challenges. To what extent are we okay with a machine making a decision to take a human life, and policy decisions that are very important, but maybe not as relevant to our conversation today because we are not, ethicists and lawyers. We are robots people, right? So I want to focus the conversation a little bit more on the technical challenges, which I think this document does a really good job of laying out. and talking about what is our responsibility as roboticists to, engage with these technical challenges. So the article, I think, does a really good job laying out some of these technical challenges, talking about the need for meaningful human control. So what exactly does meaningful human control mean? Especially with the advent of artificial intelligence and computer vision, these are technologies that can be, number one, hard to explain to the users exactly how they operate. Number two, they can be hard to characterize in uncertain situations or situations that are different from the data that the machine learning systems see in training. And so those interactions are really important for us to understand as a community, as the people who are making this technology. So I really just wanted to bring up a couple of questions that I think this article brings up of, how can we as roboticists ensure that we are putting out this technology into a policy and testing and validation landscape that is in accordance with our beliefs and with the ethics that we, put forth as a country.
So I'm going to actually tie this to the commercial sector more than I think I was planning to at the beginning. But if I'm thinking about the keywords here, it's decision-making, scale, and liability. And that third one, determining, for example, if we have a trolley problem with an autonomous vehicle, you have a choice between killing an adult male or a young child. You have to make that decision in the algorithm. How does somebody manage that from a company level, from the engineer level? What are the considerations you have to make? And ultimately, now we're dealing with scale on top of that, where a single person, maybe an engineer, is going to be the one that is responsible for how that algorithm is built. And the people who are managing the company actually don't know how it will respond in this exigent circumstance. So being very clear about what we're trying to achieve as engineers in this space, I think, has never been more prescient. Mm-hmm. Anybody have any questions based on what Walker and I just said? Afraid to touch the topic?
One thing I was thinking about is you bring up a great point, Walker, at the initial part, which is that when it comes to control, navigation, a lot of the military and weapons and defense have had a level of automation already. And it seems like from this article and what y'all are discussing, it seems like one of the crossing lines is almost like, as much as I'm embracing and excited about the road to autonomy when it comes to construction, it's that road to autonomy when you cross over from the human flying the drone, from the human operating the quadruped that's going into a tunnel or a situation on the battlefield. It seems like that it's like, at least there's a human involved in the process. And so to your point and Michael's, then all of a sudden you switch to an AI or autonomy, you really have, that's where everything has to be programmed in to the algorithm, so that how does it make that decision? How is it equitable or fair? Because you're in a situation that's very dangerous, whether that's domestic, whether that's, on a foreign battlefield. You have situations where it has to make choices that humans have a hard time doing, right? I mean, we saw that in movies like American Sniper. Do they shoot a woman who's approaching a guard post? There's all kinds of those hard choices. So I think that's going to be the biggest challenge, is switching from the human, which is tough enough, to that AI algorithm. But having a common language and common understanding at least maybe makes it where it's possible to make that bridge.
Yeah, no, I think that's a great point, Sean. And I think that question of when do we switch over from a human making a decision to an algorithm making a decision can sometimes be a sticking point, but I don't know that it needs to be. So the Department of Defense, in their very limited addressing of this issue, was Directive 3000.09. They talk about in accordance to international human rights law, we actually have to have human liability for all of these decisions that end up in a machine taking a life. So there has to be a sort of chain of liability, and in the military, it's this chain of command that is drawing back the responsibility for making that call to use this machine in these particular settings, in these parameters, in this environment, back to a specific person who can be liable. Now, there are a number of issues with this that increased autonomy brings into the fold. First, we have to communicate well between industry and academia, the people who are developing this technology, and the military people who are using it, to ensure that we're not exaggerating the capabilities, that we are thoroughly testing these technologies, not only in the environments that are, our clean lab spaces, but also in the environments where dirty, where sensor information is bad, where communication is dropping out, in these environments where they're actually be used. And then there's, of course, the question of do these liability structures actually function correctly? I feel like as we've seen, recent issues with Boeing in the news, we can trace back the liability of, these technological and installation failures that have resulted in the loss of human life. We can trace those back to maybe executives, maybe overall governing changes, but it's rare that anyone actually faces consequences for these actions. So when we incorporate these more and more complex technological systems, I think we want to avoid a situation where all of a sudden we throw our hands up in the air and there's such a complex, relationship between all of the moving parts that no one actually is responsible for a decision. I think that's a really scary idea when we have human life on the line. And I think a final component of that is making sure that when companies are contracting with governments, it's very clear in the contracting language, and this was another point brought up by the article, it's very clear in the contracting language exactly what parameters things are supposed to be used for. There is flexibility built in so that they can update the systems to be, in accordance to new guidelines, the issues like that.
There's an interesting paradigm there, Walker, where even outside of the realm of autonomy, it's harder to blame or at least see consequences for a CEO or anybody who's of a larger organization or at the head of a larger organization. Even the president, we kind of disperse blame for situations or allow for tough decisions to be made that could actually cause harm to large groups of people. So in some sense, if you take that risk away from a single operator from making that decision, you're always going to lead to actually less consequences for the person that's liable. And I think at some point we actually have to make some decisions on that societally when we're willing to tolerate that level of dispersed blame.
Yeah, exactly. I think that can be a dangerous mechanism when human lives are on the line.
Well, I want to end on a positive note. So what do you see in terms of the development of practices here that is hopeful for how we will deal with this liability in the future?
Mm-hmm. Yeah, I think the positive developments that I'm seeing around this issue are mostly in the increase in serious consideration in the the communities that are developing this technology. So we had a couple of years back, we had one of the very first discussions on this topic at the International Conference for Robotics and Autonomy, and that was a well-attended discussion. And now we're seeing more and more meetings of professionals, academics, to discuss and make sure that we are putting in place the the guidelines and funding the research necessary to make sure that these these technologies actually uphold our values. So I think that's the positive side. I think we do need to see much more funding and attention paid to the work that goes into making sure that these projects are deployed in as ethical a way as possible, and that they're respecting international human rights law, and that we're updating the international laws to incorporate this new technology.
Well, I think that's an excellent point, an excellent way to end the show. I want to thank our guests for their participation. You've been wonderful, and you really brought some great stories and insights today. I also want to thank our sponsors one last time: Airspace Link, ASTN Group, Carasoft, Drone Responders, and Axon. And the audience today, no chat, but we actually had like 25 people just on my Twitter alone. So I'm sure we had almost 40 of you throughout the course of the episode today. Thank you so much for tuning in, and everybody who's going to see this in post. We are out here.